Next problem set in the circle chapter, arc lengths and area of sectors. So you got to remember two formulas, which aren't really two new formulas if you've already memorized the area of a circle formula, which is pi r squared. If it's not the whole circle, you just multiply by the fraction, like this one, for example, 40 degrees from this line. So from this horizontal, let's say, instead of the whole 360, you only have 40 degrees. So you just multiply by the full circle area, pi r squared times 40 over 360. As simple as that. So not a new formula, really. Similar for arc length. The circumference of a full circle is 2 pi r. So you multiply by the degree that you want instead and multiply by the degree over 360 again. Okay, so no, not two new formulas really. And actually those formulas are even easier if you have the angle in radians instead of degrees, which this book doesn't even mention. So if you know those formulas or in terms of radians, it's even easier. Okay, now let's begin. In the figure above, arc AB is an arc of a circle with radius 27 centimeters. If the length of arc AB is k pi, what is the value of k? Okay, so this is the length of the arc, which is k pi. How do we get the length of an arc? Again, it's 2 pi r, the r is 27 in this case, times 40 over 360. This is the fraction of it. A fraction of the full circle. Okay? Now you just simplify. So you can get rid of one of those zeros there. This would be a 4, this would be a 3. These would cancel. So then that would be 6 pi. So k is 6. Okay? If the area of sector OAB is n pi, what is the value of n? So if it's n pi equals area of a sector pi r squared. What fraction of the full circle? 40 over 360. Okay, where r, again, is, let me fill it in, 27 squared. Okay, now we go through the motions of simplifying. And so if you're not allowed a calculator for this, how can you simplify this? Again, we can write this as pi times, that'll be a ninth, right? A ninth times, what's 27 squared? Can't we write it as 3 cubed squared? 3 cubed is 27, right? So how can that help us? Well, this is pi times this we can write as 3 to the 6th power, right? And 9 is 3 squared. So this is just 3 to the 4th power, which is 81. So pi times 81, meaning our n is 81. So this is a little algebraic hack. If you're not allowed a calculator, you have to think of it like that. Otherwise, you have to evaluate 27 squared and then divide by the 9, which is not bad, but I'd rather do it like this. I try to avoid tedious multiplication and division if possible. The figure above shows arcs of length 8, 7, 6, 5, and 4. If measure of arc AB is 120, what is the degree measure of angle A? Maybe to clarify, this is 120 degrees, okay? Not to be confused with the length of that arc. Clearly, that doesn't add up to 120, right? So how can we solve this? Maybe we can find what the radius is, I'm thinking, because the length of the arc, which we know, that whole arc AB, what's the sum of all this? This is what? This is 13 plus 8, that's 21 plus 9, that's 30, right? The whole length from A all the way to B is 30. 30 is equal to 2 pi r times 120 over 360. Okay? Again, 2 pi r is the circumference of the whole circle. We only want a fraction of it. Okay? Now, what's 120 over 360? That's a third, right? So 90 is 2 pi r. Okay? So the radius is 45 over pi. 45 degrees over pi. This is weird notation in my opinion because this is in degrees over here. Actually, this... Okay, never mind. This is a correct length. Never mind. That's right. Okay. I got confused myself. Okay, so this is the radius. Now we can find this angle because for just this sector over here, the arc length is 8. So 8 is equal to 2 pi times, we know what r is now, 45 over pi, times a over 360. Okay? And then we go through the motions of solving for a. So this would cancel to an 8 over here, and then this would be a 4 on the bottom. So 8 equals a over 4, so a is 32. That's the answer. Okay? So again, this one, you have to think a little bit carefully. Why did they give us this piece of information? We got to probably use it, unless it's a distraction, but it wasn't in this case. We know this entire angle is 120, and we know the length of the arc, so we get the radius, and we can use that radius to get this angle over there, because we know the length of this arc over here. Okay, in the figure above, radius of the circle is 8, and measure of angle AOB is 120, so maybe let's even mark that, 120 degrees. What is the length of AB? Well, isn't this AOB an isosceles triangle? Because this is also radius. Right? So, let's draw the triangle. Oops. Pretend that's straight. Okay? We can draw a bisector. So this is 60 degrees. It will also bisect that angle. This is AB over 2, let's say, and this is 8, right? So, what's the relationship between AB over 2 and 8? This is 30 degrees. We can fill that in. So, if this is 8, this is 4, and this guy should be 4 root 3 by our 30, 60, 90 triangle. So, therefore, AB is 8 root 3. Now double check. Yes. Okay. Again, the previous concept came in again. You got to know them still. All right. Last one in the set. In the figure above, OP equals OQ. OQ, okay? And PQ is tangent to the circle O. The radius of circle O is 8. What's the length of QR? Oh. Where's Q? I'm like, if this is Q, QR, that's the answer, the radius. But this is QR over here. Okay. So again, tangent to the circle, so we could probably draw a representative radius here, because it's tangent at that point. Okay, it's 90 degrees. How does that help us? Well, the radius is 8, so over here it's 8, and over here is 8 as well, actually. This is also a radius. So now we can get OQ, or QO, let's say, because I already wrote Q. QO is 8 times 2, which is 16, which is OR plus RQ. We're solving for RQ or QR, same thing. So what's OR? That's 8. So RQ is 16 minus 8, which is 8. That's the answer. Okay. So here you had to be able to see that these two were radiuses, or radii, and then 30, 60, 90 triangle. Okay. Again, previous concept came in again. All right. Hopefully this is a good practice set, or again, if you got stuck, hopefully you saw how I thought through the problems. Hopefully you can imitate that next time if that helps you out. All right, as always, please like and subscribe if you found this helpful in any way. Hopefully I'll see you in the next video as well.